All right, thank you. My name is Brian Rishikof, and I'm one of the founders of Odyssey. Sorry. Yeah, no problem. Oh, hello again, still me. Um, I'm also known as the guy with the probably 30 or 40 removed before flight tags on my backpack. So, in fact, I have so many people sort of stop me and give them to me when I go to conferences and things. So first, I actually want to ask some questions. I know there was a question about, are you reticent to raise your hands? And if that is true, then this won't work. But I am curious, how many people here were here last year? Okay, so it's a good number, a little less than I thought, which is good because I have some repeat material. Uh, Also, this is sort of get to know your audience. Who's a flight software developer? All right, that's most everybody. That's great. A little bit different. Maybe you put yourself in developer category anyway. Who's a flight software architect? Oh, they're great. Great. There are some of those out there. Who's a flight software manager? Maybe you hold more than one role. There's one. I know at least one of you out there. And I'm sort of curious, what fraction of you who's a presenter or author? Oh, great. And then this one would have worked better yesterday, but now that we're in a different room, it kind of works. Who's just now realizing they're in the wrong place? All right. So first, a bit about Odyssey, if you don't know us. So we started really as a guidance navigation control company over 20 years ago, actually. And sort of to do GNC right, you have to move into simulation and analysis, which is effectively software tools, software analysis. And we got good at that with the algorithms and the software. So we started to do flight software, and mostly at the time, guidance navigation control software. And sort of an extension of that for us was sort of loading the software onto your avionics platform. We don't design those platforms. We can help design those platforms, but that seems like a natural extension once you're doing flight software. And then once you have that, well, the next thing to do is to operate it in space. So we do some of that. We're based in Houston, so most of what we do is sort of related to our customer down the street, but not all of it. But here, oops, oh yeah, see, I made some changes that didn't get loaded, so I'm expecting them. Sorry for that. So because we work at Johnson Space Center, a lot of the work we do is Class A. So it has to have the highest level of certification and rating for transporting humans or working in a human environment or related to human spaceflight programs. And that means you do a lot of detailed testing, documentation, creating of artifacts, driven principally by the NPR 7150.2D and by DO 178C, especially if you're doing reentry or launches or things like that. So we spend a lot of time here. And one of the biggest things here that drive reliability is redundancy, fault detection, isolation, and recovery. We have to know something's going wrong. We have to make sure either that we can execute the mission or bring the crew home or ensure we don't damage anything. So the sort of the running premise is 1 fail operational, 2 fail safe. So we do a lot of that. So the first thing we did as a company 20 years ago was work with the space station. And the space station is in ADAS. We weren't doing that. We had a lot of people that worked the space shuttle program, which also, use some unique things, have, a lot of computers for voting and all that. So we took that knowledge and also the rendezvous and prox ops, which was a big thing we did, and we turned that into sort of stuff we were doing effectively with NASA or representing NASA with the international partners. So a lot of you are young. You may or may not know these spacecraft. The top one is the European Automated Transfer Vehicle. It was developed and did several missions to dock with the Russian segment on the space station. So it was a docking spacecraft. And it had no people on board, but it was docking to a spacecraft with lots of people on board and worth, pick your favorite big number, 50 to $100 billion. The next one that flew was JAXA. It's the Japanese Space Agency, the Japanese Aerospace Exploration Agency. They developed the HTV, H2 transfer vehicle. It flew on their H2 rocket, and it flew to the US or international partner segment, and it was captured by the robotic arm. So you get pretty darn close. You go into a sort of a coast free-floating mode, and you get grabbed manually by the crew to berth. It gets attached to the space station. These were two pathfinding projects, a really big deal. So another more recent Class A project that's doing things called it the traditional NASA way is Orion. I think this is the only picture I'm reusing from last year because I love this picture. This was from the Artemis 1 mission, which flew very, very far past the moon and took this great selfie back with the moon and the Earth in view. So all of you are in this picture. And it was really great to be a part of that mission. It was really done the old-fashioned way. There's a lot of old process and old requirements levied on this heavy Class A mission. It hasn't flown people yet, but it will in as early as February of next year on the first flight with humans on board. So everything has to be Class A. And fun fact, we had one of the Artemis 2 astronauts in our office giving a good motivational speech last Thursday. So that was cool. So also moving forward, this is Gateway. So Gateway, actually, parts of it don't use CFS, but parts of Gateway do use CFS. And so this is sort of this evolution to start to use things and do things a little differently. This is also, this is not what it will ultimately look like. I think this is a relatively recent grab from NASA, but it's intended to be a big international partnership with different segments, an airlock, a habitation module, et cetera. And it's a kind of a staging location for exploration of the moon. So then, we started moving into so-called commercial at some point. This isn't really time sequential, it's more concept sequential. So we went from sort of doing things the way NASA does things, and we learned a lot of lessons, but we started to do things sort of called commercial. So commercial space has been around a very long time. Satellites are commercial, all kinds of things are commercial, but the so-called new space is doing things a new way. And that makes a lot of sense to us. So one of the things we did, and this is sort of fun, I just like to show it because it's fun. Back in 2011, the iPhone 4 came out, and I'm a bit of an Apple fanboy. So we wanted to do something and show you can take off-the-shelf items and use them in space. So we wanted to fly the first iPhone in space. We made the first space app. We actually coined the term space app, and I wish we trademarked it, but we didn't. So this was the opening segment, which I like. And in the end, we wanted to do a kind of guidance navigation control experiment, but because of ITAR, we had to make it pretty dumb. But Apple invited us to do the Worldwide Developer Conference. We had a ton of fun. So this is actually the opening sequence of the app, and it's in this iPhone format. And the phone tumbles to the screen, and then the screen basically transitions to the actual app that you use. So it becomes touch sensitive after the little video. So we had tons of fun doing that. It was an interesting exercise to show what you could do with off-the-shelf products. And it was sort of our dipping our toe in the water with commercial. After that, NASA embarked on a commercial orbital transportation services COTS contract. And it was called COTS with that, call it backronym, because they wanted to give the impression of commercial off the shelf. They were buying services, not spacecraft. We ended up partnering with SpaceX early on, and SpaceX first flew successfully. We partnered with them on GNC, and we ended up working with them to do some of the software work. We partnered with Orbital on Cygnus, and we ended up doing the same kind of design and ultimately some of the software work with Orbital. Both of them flew successfully. Both of them are still flying. Crew Dragon was an evolution, so they started transport people. We continue to work with them on that project. It's a ton of fun. We're working on Dream Chaser. So Dream Chaser is behind schedule. We're helping develop the software for Dream Chaser. That's supposed to fly this year. And that's another cargo transportation spacecraft that joined kind of this commercial environment kind of late. There are now there will be 3 commercial providers, which offers real competitive environment for doing this kind of work. So things have to work. The Class A software has to work. So then we sort of came up with this idea of commercial Class A, because all of these projects that I've described are creating software internally that is all bespoke, created content, which is very expensive, very time consuming. If you all work software, you kind of know software is always last. Part of being last is because you have to fix all the other problems when they discover them during test and whatever. But part of it is also because it takes time, and you always can do one more thing. So we wanted to reduce the burden of creating software that can still be certifiable to Class A. And on the keynote opening the conference, they talked about an iterative approach to developing technology. And every time you create software, you are developing technology. So we incorporated lots of these lessons, our own lessons from 20 years of working with other programs, to come up with an approach that we call commercial Class A to make software that is of the highest quality, but much lower cost. So really, it's design, implementation, test, agile processes, built-in quality gates that achieve the comparable level without the same cost of overhead. And part of that is, of course, reusing infrastructure and automation and other things like that. So we embarked on this intentional evolution to products, leveraging these 20 years of doing this kind of work. We wanted them to be configurable and customizable because, you know, now there's commercial space stations, there's other commercial transportation systems. A lot of the elements of the future infrastructure, even from the government, is awarding multiple awards so that commercial practices and commercial pressures are in play. Even the Department of Defense is trying to incorporate commercial approaches to execute more efficiently. So customer benefits, these were the tenets, right? It has to be lower cost, it has to be lower risk, so that's the Class A quality, and it has to reduce your schedule. And in the commercial environment, that's critically important. Everybody, especially if you get external investment, you need now, or yesterday. And of course, it has to be high reliability. This is our commercial Class A approach with lots of testing and automation. So the products we developed, I wish I could skip a slide and then come back, but this is where we are. So we have a flight software framework. I'll get into each of these. We have a development and test ecosystem. We did create sort of a library of guidance, navigation, control, because that's what we know best. And that's also configurable and reusable, and we call it flight software ready. So you can use it in your simulation, in all your testing, and on your spacecraft. So you're basically, you know, there's a motto, right? Test like you fly. And then core flight software has been part of our core capabilities for over a decade. And so it's still part of the landscape. It is still something we actively support. Not everything is an answer for every problem. So to have some choices is healthy. So this is the one I wish I had before. So we were developing all this, or a lot of this in one bubble. And we, you know, the working name was Flexible Odyssey Flight Software Framework, or FOF, but we didn't think that would work very well. So we changed it, and that's why it became Encore. And Encore was chosen because, you know, there's core flight software, and it's been around a while. And we thought this is the next thing, you know, give me more. So this is Encore. It borrows some of the tenets. There are some great things in the CFS design and architecture, but we really did take it forward. It's our what we call our commercial Class A flight software framework. It supports execution on a single computer or distributed computing nodes, and it has what we call behavioral determinism. We manage time in a very special way so that when you're testing, you can test and guarantee things will operate the same way within the limitations of the hardware. But it means also that if you're doing emulation in software, you're only limited by how fast the software can go and how fast your processors are. And that allows you to do, and in our world of Class A, it's very important, to do statistical analysis much, much faster than real time with your flight software in the loop. So that's a pretty important step forward for the kinds of statistical work we do. A lot of the requirements are not just black and white, they're statistical in nature. So you have to generate a lot of data. We support user-defined distributed avionics architectures, and we talked about the time synchronization and the data exchange, et cetera. We promise safe code execution from through compile time checking and a lot of error handling that's built in. We have a lot of FDIR, fault detection, isolation, recovery. That's built in. That's one of the hardest things with our experience. That's one of the things we really wanted to bring to the table. And we support Byzantine fault-tolerant architectures and all kinds of other fault-tolerant implementation. So Stage, so originally, the flexible Odyssey flight software framework, Stage and Encore were blended. And we realized they're really two distinct things. So we created a development and test ecosystem and the framework. So this, basically it has all the elements to create, we can all read and configure your whole flight software system. It has a large tool set for creating and configuring your tests, writing your tests, your success criteria, analyzing all your results, and even automatically generating reports. So this is great during your execution. As long as you have operational flight software, you can do stuff. You don't have to throw anything away. So there's a reduction in lifecycle cost too. You have tools for moving data. Again, a time synchronization with your framework, network simulation, failure injection, which is very important for the kind of work we do, and packet manipulation, and then basically a single source of truth for managing your data. And then even though we were developing it in conjunction with our framework, they really are distinct. It's framework agnostic. It will support CFS. It will support our Encore framework, and it's configurable to support other frameworks. And of course, this is actually what enabled our commercial Class A process. So we use it to create all the things we're doing. So for GNC, so we've been doing GNC a long time. This is how I characterize our evolution for GNC. We were creating things always bespoke, sometimes configurable, simulation, sometimes flight software, algorithms, MATLAB, whatever. And it's like going into your garage and you're like, I have this big mess of things. I have tools all over the floor. Some are dusty, some are rusty. We collected that all. We put them on the pegboard in the garage, found out what we were missing, found out what we need to polish, found what we needed to replace. And so we've created this library of reusable models. A lot of what we did was rendezvous and proximity operations. So it's really all the orbital stuff, all the rendezvous stuff, with all kinds of different sensor models that are configurable and lifecycle adaptable because of the flexible fidelity. It, of course, leverages some of our Encore work, and it extensively utilizes our Stage ecosystem to make sure it is Class A certifiable. So CFS, it's another thing we've done a lot of. So 14 years working with CFS. We've done projects that include attached payloads on the space station, some free flyers in low Earth orbit. Orion, actually, I don't know if you know this, Orion main flight computer is not CFS, but the backup flight system is coded in CFS. And the backup, of course, only gets invoked on a critical failure of the primary system, which is redundant. We actually worked with the Laboratory for Atmospheric and Space Physics on the Emirates Mars mission, which is core flight system, and that's flying around Mars right now. And we have more things in development. All the things we can't talk about, but some things we can. So we've been working with the full CFS stack. lots of operating systems, real-time operating systems, different flight computers, all the, I'll say over 14 years, lots of versions of CFS. CFS is open source. One of the things we've learned is free isn't free. There's a lot of work to do depending on the class of mission. So CFS is great for a lot of things. There are some things it's less great. And so we're trying to offer an alternative. And what we offered actually is scalable. We have scaled our software products, from the very complex down to the very simple. We even created an instantiation of Encore we call Encore Lite. It's very basic. And the idea was you inherit, regardless of your application, this high level of robustness. It could be a satellite, it could be a space station, it could transport crew, or it could be a rocket going up and down. So we really wanted to be able to offer the capability of this high quality applied to any space project. So we've also developed, we've augmented a lot of the open source CFS. So you can go get CFS, and then we have lots of other add-ons that we've created. We have support tools for working with Stage and Cosmos OpenC3. We have modern C++ support built in, Encores in C++, so they will play nicely together. Yeah, we've done the whole, life cycle of development. So last year, we called it our unveiling of our commercial Class A, introducing commercial Class A. So what's happened in a year? So we looked at what we were doing, and even though our guidance navigation control is severely constrained by ITAR, International Traffic and Arms Regulation, the framework was completely agnostic and didn't include any of that content. So we pursued the State Department, and we achieved basically a non-ITAR commodity jurisdiction determination, which is a big deal. Then we went to the Commerce Department, and forgive me if I'm boring you, but this is part of the process. We went to the Commerce Department to see if we can export, and we got a classification called EAR 99. Don't even ask me what EAR stands for. But that means it's the most liberal export permission you can get. So that means our stuff can be used internationally. So I didn't have to worry about making this presentation for international conference. The other thing we've learned, there are some things out there you can license. And the feedback on the licensing models were mostly frustration from customers. So we wanted to offer a creative licensing model. And if you, especially for so call it the initial class of projects we envisioned, it was these large space projects where a lot of things are done in-house, typically. So they're vertically integrated. And that is a model a lot of organizations are choosing. But I say, no. You don't actually want vertical integration. What you want is control. So we offer a licensing model that gives you control over the end product. And if you want to learn more about it, come and talk to me. I've just been given the timing thing. So we are going to be deployed on the Venturi Astrolab lunar terrain vehicle. It's in competition with others, but it will be deployed on the moon on the first Starship launch that actually lands on the moon. The commercial instance will go to the moon on the Starship. We also got an international customer. The exploration company is based in Munich in Western Europe. It's NIX. They're building an independent transportation system because as space station has retired and they go to commercial space stations, Europe wants its own capability. They have chosen to use our framework and our ecosystem for that development. And another one also signed up, but I can't tell you about it yet. And our first flight is coming up. It's also with Venturi Astrolab. They're flying FLIP, which is the Flex Lunar Innovation Platform to demonstrate technology. And it's slated for launch in December 2025 with Astrobotic. And this is what it looks like. It has full-scale technology, so it's not subscale. It's not testing everything, but it's testing key technologies, and Encore will be on that one too. And we're currently working on another flight demonstration opportunity, so maybe we'll report on that next year. So we are a sponsor. We love it. It's our second year being a sponsor. We appreciate everyone that comes. We think this is a great environment for exchanging ideas and frankly, for showcasing our stuff. So we have a new demo. It looks the same as last year, but it's different. I encourage you to go look at it. We've got Encore playing on multiple cores with another core with CFS. So to show the interoperability, this is what it looks like. And I'm going to ask Joel, wherever he is, to say a few words about what you can see.
I'll truly make it a few words because we're extremely out of time. So come on by. We're showing voting. We're showing fault resilience, and you can lose a node. You can bring a node back. We're testing with stage. We're doing interoperability live with CFS. We're doing time synchronization. Lots of cool technical things because that's what Encore and Stage let you do. 10 seconds. Sorry.
Sorry for taking so long. I was out of kilter. I was watching the clock, but I was supposed to be earlier and all the timing thing. But that's all. That's all we got. I don't know if there's time for questions.
No. Any questions? Okay, man. Okay, we'll take one.
What is more difficult, the technical stuff or the legal stuff?
You know, they both, I'll say the legal stuff is more difficult because you have no control over the outcome, and it's a landscape, at least, you know, we've hired professionals, but it's a landscape we aren't trained to address.
All right, that's it. Thank you so much, Brian.